We're going to begin Calculus Chapter 5, Section 1 with the extreme value theorem. And I would encourage you to pause and write this down before I start to explain it, which is, we talked about before about finding relative extrema based off of where the function changes from increasing to decreasing. That would be a relative max, or decreasing to increasing. That's a relative min. What we're going to investigate now, though, is absolute extrema, which is the, I'm trying not to use the word absolute, but either the greatest y value or the least y value throughout the entire function. Now, sometimes what we do is we truncate the function, so we have a given interval, and those absolute extrema could happen at the endpoints. So if I gave you a couple functions here, what we could do is first look for relative extrema, and that's exactly what we talked about from the previous unit. I'm just going to assume that the points are perfect. You know, we're looking at -3, 0, -1, 3, and 2, -6. So just so I'm clear with my notation, whenever I ask for the extreme values, I'm talking about the y values, and then the x will be the locations that they occur. So as we look at these three values, we do have an absolute extrema. There's an absolute min at 2, -6. Now sometimes you'll see me say the absolute min value is -6 at x equals 2. You know, you might hear me say things like that. What about an absolute max? Well, if you look at this, there is one relative max, but it's not the absolute highest on the graph. It does go infinitely up. Well, as we look at the second graph, I kind of want to wait for that third question. The relative extrema, again, we're talking about these points. So we're looking at -3, -4, -1, 4, and then also at 3, 2. And as we look at the domain on this, what are the coordinates of the absolute extrema? Well, our absolute min is down here. So absolute min. Again, the value would be -4, but I'm going to give you the order pair, -3, -4. So the absolute min value is -4 at x equals -3. And this time we do have an absolute max. And that occurs, well, not at one of the relative extrema I had earlier, because we can clearly see at 6, 5, we have the absolute max on that interval. So the premise that we're going to be getting at is that sometimes the relative extrema could also be the absolute extrema. And in the same concept, the absolute extrema, well, we might not even have absolute extrema in the case of f of x over here. So let me just get a good definition for you. So looking at the answer key, we can see that on the graph of f, the absolute min did occur at the relative min. I guess you could say the same thing about g. However, the absolute max did not occur on f at all because it went infinitely up. F went infinitely up, so there was no absolute max. And in g, the absolute max occurred at the endpoints, one of the endpoints. Now, don't automatically assume that that's the case for absolute max, because I could have flipped all those graphs. and the absolute max would have occurred, and then like f, if I flipped it over the x-axis, it would have had no absolute min. And same thing with g, is I could have flipped that. So what we'll be investigating with the extreme value theorem is where those absolute extrema occur. So looking at the same graph, we're just kind of moving forward. So what are the absolute extrema? Whoops, I did not read carefully. -2 to 3. So we're going to truncate this problem. And I know it's not exactly at -2, 2, but this graph is not perfect. To 3, I think it's supposed to be right here. Now when there is an interval, we can definitely tell that there will be an absolute min and an absolute max. Again, if you ever forget what to do, just give the ordered pair, but the min value is the y value. So as we look on this interval, I guess if you really wanted to, you could imagine for a second like you took a marker and you covered up this space over here, and same thing with covering up this space over here. So we're only looking at this piece. I don't really like that though. It's just, I guess, a personal habit of mine. So the min value occurred down here, and we're just going to say it's about 2, -6, because I know the graph isn't perfect there. And then the absolute max occurred, not at the endpoints, but at this relative max, -1, 3. And you can do the same thing by just looking at a different interval from -4 to 1. So -4, I don't know, let's say it happens at 4. It's really tough to see if it's 4 or if it's at 5, but it's definitely higher than this point. And if you look at 1 right there, well, there is a relative min, but it's not the absolute min because it's smaller over here. So the absolute min is at 1, the endpoint, -3, and the absolute max was at, let's just say -4, 4. I know it's really tough to see, and when I flip back to the answer key, you might see a different answer. And then the same thing for G. Let's just change colors and look at G from -4 to 5. So -4, looks like that's perfect right there. Goes down, back up, down to 5. So there is an absolute min, and looks like it's occurring at the ordered pair -3, -4. And this is actually why, if you look at the absolute max, because it is possible to have more than one max, but there's only one max value. And that's why sometimes we get into this notation of the max value is 4. And where does it occur though? Well, it occurs at 2 different places, but there's only one absolute max. It's kind of like if you had a bank account and you said the most money I've ever had in my account was $1,000. And but that most amount might have happened twice in your life, like maybe when you were, I don't know, 15, and again when you were 17. You know, just kind of making up numbers here. So that max value happened at -1 and x equals 5. But there's only one absolute max value. And hopefully that makes sense. Now let's look at some different values from -2 to 6. It looks like the absolute min at -2, 0, and an absolute max at 6. I think it went up to 5, right? Yeah, let's say it's 5. Well, the whole point of this is when we restrict the domain, we could have extreme values at 3 different places. And I think you've heard me say quite extensively, one of those that could happen is at the endpoint. Endpoint of those restrictions, -4, 1, -2, 3, -4, 5. negative 2.6. It could happen where that derivative, where we had a horizontal tangent. So let me just write where f prime, because f or g, doesn't matter, is equal to 0, or f prime does not exist. Like in the case in G over here, we had sharp turns. So let me just switch back to the answer key. That's exactly what they have. So you might want to pause the video. Notice that he went ahead and wrote the point still up here, but notice it's one max value, and it could happen at 2 different points. Yeah, so that's where our potential absolute extrema could exist, can exist, whatever. So let's get to the extreme value theorem. This is how it's written in a textbook, which I always struggle writing the way a textbook does. And hopefully you can forgive me for that. So if we have a continuous function on a closed interval, notice it has to be a closed interval. If it's an open interval, then we would not have an endpoint to check. Okay? Like if you were to say the open interval from, I don't know, 2 to 3, well, what's the upper bound for 3? Is it 2.9, 2.99, 2.9999? And we have a dilemma. So it has to be a closed interval. Then there exists an absolute maximum and an absolute minimum on that closed interval at either x equals a, the first endpoint, x equals b, the last endpoint, or any value of x on the open interval between the two of them, such that the derivative equals 0 or the derivative is undefined. That would be like a sharp turn. Notice that you cannot have a vertical asymptote, because if you did, we would not have a continuous function. So as a reminder, you could be an undefined derivative but still continuous. But if something's differentiable, then it's automatically continuous. So things like that. Yeah, pause the video. I think I'll just go back to my notes. So back in the notes, the absolute max, we already have the graph drawn right here. But if we were to find the absolute max based off the graph, I would commit to the max value. Is 6. Now as far as the where does it occur, you might want to say at x equals negative 4 and x equals negative 1. Sometimes they don't even ask for those values. The absolute min on that interval looks like it occurs at positive 1, but that absolute min value is 1. Looks like we had the same question asked a couple of times. Because maybe they wanted the relative. I don't know. Well, let me put it this way. What we'll be doing is we'll be taking the derivative of the function. So if we did that, we'd have negative 3x squared minus 12x minus 9. And we're going to set that equal to 0. Now, if I were doing this, I would factor out a negative 3. So we'd have x squared plus 4x plus 3 is equal to 0. So we could factor that at x plus 3, x plus 1. And then we could set those equal to 0. We would have negative 3 and negative 1. So what we would do next is use a sign chart. And you don't have to use a complete sign chart, but all you have to do is create a chart that would say, okay, we're going to check the endpoints and where the derivative is equal to 0, and plug that in, f of negative 4, f of negative 3, f of negative 1, and f of 1, and use those values. I'm going to cheat because I'm running out of time. And the highest will be the max, and the lowest is your min.